The Milky Way, black hole or mystery? At the center of our galaxy lies a profound mystery. A mass so enormous it sends stars into dizzying orbits. Around it, the environment seethes with energy. Most scientists agree it is a supermassive black hole. But what if we are wrong? What if what lurks there is not a black hole as we know it? What is a black hole and how does it form? A black hole forms when a very massive star, at least 20 times the mass of our Sun, reaches the end of its life. The outer layers explode in a supernova. The core collapses to a point so dense that its gravitational pull is strong enough to prevent even light from escaping. Supermassive black holes, like the one at the center of the Milky Way, form differently. They accumulate enormous amounts of stars and gas over millions of years, possibly merging with smaller black holes or collapsing from early massive stars known as population 3 stars. The black hole at the center of the Milky Way. The object at the center is called Sagittarius A star. Its mass is estimated at around 4.3 million times that of the Sun, concentrated in a very small region. The evidence is clear. First, stars orbit the center at incredible speeds. Stars like S2 move along elliptical paths that reveal an enormous concentration of mass. Second, hot plasma and accelerated gas are observed in radio, ultraviolet, and X-ray wavelengths. They show matter behaving dramatically around this central mass. All of this supports the idea of a supermassive black hole. But still, the full picture may be more complex. Empirical evidence for star consumption and the lack of evidence here. In other galactic centers, astronomers have observed tidal disruption events, or TDEs. These occur when a star ventures too close to a black hole, is pulled apart and swallowed. The process emits intense radiation, detectable across the galaxy. At Sagittarius A star, however, such events have not been clearly observed in recent decades. This teaches us something important. The central mass is immense, but we have no direct evidence of a single object being swallowed. Only indirect indications of energetic activity. In other words, the process is possible, but rare or extremely slow here at the heart of the Milky Way. Alternative hypotheses. A. Massive compact object, or MCO. An MCO is a very massive object concentrated in a small space, enough to generate the strong gravity that explains the star's rapid orbits. It could be composed of several components: neutron stars, remnants of massive stars that exploded in supernovae. Their cores collapse into tiny, ultra-dense spheres, roughly 10 to 20 kilometers across, with a mass of 1.5 to 2 suns. White dwarfs, remnants of medium-sized stars like our Sun, which burn out and shrink. Extremely dense, about the mass of the Sun compressed into the size of Earth. Or a mixture of these stars and dense gas, forming a concentrated mass without creating a full black hole. B. Boson star. A boson star is a theoretical, ultra-dense object composed of particles called bosons. Bosons can occupy the same space without restriction, allowing vast numbers to gather in a tiny region. The result is a mass almost as dense as a black hole, yet without a singularity. Matter and light can still escape in principle. Boson stars could explain the rapid orbits of stars near the center, but so far they remain purely theoretical, without direct observational evidence. So what really hides at the center of the Milky Way? A supermassive black hole? A massive compact object? Or something else entirely? One thing is certain: the heart of our galaxy still hides secrets, and we are only beginning to understand their depth.